All right, so guys, the second part of this basics of functions is the number sets. Okay, all of our different kinds of numbers. All right, a lot of times they're going to be asking you to know the appropriate domain, meaning the x values, the kinds of numbers that make the most sense. All right, so actually write that down. Kinds of numbers that make sense in the problem. Oh. Okay. All right, so it's the kinds of numbers that make sense. And here are the different options that you have. Integers, whole numbers, real numbers, rational numbers, and irrational numbers. Who can tell me what one of these things are? Give me 1, 2, without a decimal, without a fraction. Can it be negative?
Yeah.
Yeah. Good. So positive and negative. Whole numbers. Okay, no fractions or decimals. Whole numbers are just the non-negative ones. So 0, 1, 2, 3, any of the positive numbers. All right. Real numbers are any number that you can possibly think of. Mm-hmm. It includes our whole numbers, our positive numbers, our negative numbers, things with fractions, things with decimals. It includes rational numbers and irrational numbers. It's weird. It's very lagged. Okay. All right, so here's our two big ones that we talked about. Rational versus irrational. What's the difference between our rational and our irrational numbers? Can be, yep. Good, so rational numbers can be written or expressed as a fraction. And irrational numbers cannot be written as a fraction. Okay, and in our calculator, how do we tell if it can be turned into a fraction or not? What's the trick? Math frac, yep, math frac, and which is the first one, so enter. Okay. All right, but for example, with our appropriate domain questions, all right, here's this example. Mrs. Shenik buys coffee from Tim Hortons. The total cost can be modeled by the function C of x equals 2.10x, where x represents the number of medium coffees purchased. Which of the following represents an appropriate domain for the function? All right, first question is, what does domain mean? X values, good. So our domain is our X values. And what does our X represent here? It's always going to say it right in our question. The number of medium coffees purchased. Okay, so let's think, what kind of numbers? Can we have negative coffees purchased? So no negatives. Could we have fractional parts of coffees purchased? So no fractions. Which includes, could I have like 2.1 coffees? No, so no fractions, no decimals. Yeah. but purchase. I can't go to the store and say, I'll have 1.5 coffees, you know? Okay, so first off, we want to eliminate any of the negative choices. Which out of these 4 includes negative numbers? 1 and 2. Integers are positive and negative. And number 2, positive and negative real numbers. All right. So now we have to decide between real numbers and integers, the positive version of those. Which one of these 2 cannot be a fraction or a decimal? Real numbers or integers? Real numbers can be decimals and fractions. No, it's not the answer. We don't want to have decimals and fractions, okay? We want just positive integers, okay? That's our whole numbers. We can't have partial copies purchased, okay? All right, and our final piece of functions is our favorite, our transformations. It's guaranteed to be asked, and it's simple memorization of these rules, all right? So remember, we've got g of x, that's our new part of our function, and f of x is our old function, or the original. And then we have all these different rules, okay? Our negative on the outside, does anybody remember what the negative tells us to do? Transformations, what does it do? No, what does the negative do? It reflects it. That's just one of our rules. It's the rule. It takes all of the y values and it reflects them. It makes them negative, so flips it over the x-axis. Yeah. All right. On the outside of parentheses, the a before the parentheses. What is this one? A. So when we're taking something and we're multiplying it, that's like an exponential function, right? What's the word when we talk about exponential functions? Scale factor. Okay, so these are dilations. All right, it either makes it long and narrow or short and fat. Okay, so if a is between 0 and 1, this is going to smush it down and make it go out all the way to the side. So this is going to make it wider. All right. If we're taking our function and we're doubling its height, that means we're taking it and we're pulling it to double its height. That's going to make it tall and skinny. So that's going to make it narrower. Okay. Inside the parentheses is always with x. All right. And which direction does x go? Up, down, or left and right? Left and right. So this is going to be a horizontal change. All right. And remember, inside the parentheses, it always says the opposite of what we think. So if we initially think we're going to go plus b, we're thinking towards the positives. It's the opposite. We're actually going to go towards the negatives or left b units. And if it says x minus b, that means we are going to go towards the right b units. All right, and finally, if we've got, it's just memorization. It's just remembering the rules. All right, after the parentheses, those are our vertical translations. So this means it's going up or down, vertical. And this one does what we think. So if it's plus c, it's going to go up. Minus c is going to go down. All right. You need to just have those ones memorized. And I believe you guys actually have an example there. I don't have it, do I? Nope. You do. Go ahead and try that one and we'll come around and check it, okay?